Greetings dear learners. Welcome to official YouTube channel of SRN International School, Jaipur, Rajasthan. Today, in this video, I, Faculty of Chemistry at SRN International School, will be explaining the topic Colloids of Unit 5 Surface Chemistry of Grade 12 Chemistry NCERT. As we all know that solutions are homogeneous system. When the sand is added to water and stirred, it gives suspension which slowly settles down with time. Between the two extremes, suspension and two solution, we come across a large group of system called as colloidal solution or simply colloids. Difference between true solution, colloidal solution and suspension is that true solution has the particle size below 1 millimeter in diameter. Colloidal solution has the particle size in between 1 to 100 millimeter in diameter, and the suspension has the particle size above 100 millimeter in diameter. Colloids are the heterogeneous system in which one substance called as dispersed phase disperses as fine particles into another substance called as dispersion medium, and thus a colloidal solution is formed. Types of colloids. Colloidal system is being classified depending upon whether dispersion medium or dispersed phase are in solid, liquid or gaseous, and thus colloidal system has 8 types. Gas and gas forms a mixture which is a homogeneous and hence is not a colloidal system. When the dispersed phase is liquid, which is in dispersion medium, that is gas, it forms a colloid type called as aerosol. Example is fog, aerosol sprays. Solid and gas forms aerosol. An example is smoke, airborne bacteria. Gas and liquid forms foam. Example is whipped cream and soap suds. Liquid and liquid forms emulsion. Example is milk and mayonnaise. Solid in liquid forms a colloid type called as sol. Example is paint, glaze, gelatin. Gas in solid forms solid foam. Example, marshmallow, styrofoam. Liquid in solid forms solid emulsion, for example, butter, cheese. And solid in solid forms solid sol, for example, ruby glass. Properties of colloids. Physical properties. Colloids are heterogeneous in nature. They consist of two phases, the dispersed phase and the dispersion medium. The colloidal solutions are quite stable and their particles are in a state of motion and do not settle down at the bottom of the container. Colloidal particles are readily passed through the ordinary filter papers. However, they can be retained by using some special filters known as ultra filters. For example, parchment paper. The particle size of colloids generally varies from 1 nanometer to 1000 nanometer. And the color of the colloids depend on the wavelength of light that are scattered by the dispersed particles. And the wavelength of the scattered light again depends on the nature of the particles. Another property of colloidal solution is Brownian movement. When the colloidal solutions are seen under a powerful microscope, then colloidal particles appear to be moving in a continuous zigzag motion all over the field of view. This motion was first discovered by botanist who was a British botanist, Robert Brown, and therefore this movement is called as Brownian movement. When the light is allowed to pass through the colloidal solution, then this light is scattered by colloidal particles, and these particles they execute a ceaseless, erratic, random motion called as Brownian movement. And it is due to the bombardment of colloidal particles by the molecules of dispersion medium. Another property of colloids are electrophoresis. Electrophoresis is the movement of colloidal particles under the applied electric potential. So here the two platinum electrodes are taken. One is the positive electrode anode and the other one is negative electrode cathode. And they are dipped in the solution of colloids. When the electric potential is applied, then these colloid particles they start moving towards one or the other electrodes. And thus it explains the existence of charges on the colloidal particles. Another important property of colloidal solution is Tyndall effect. When a beam of light is passed through the true solution and colloidal solution, then the beam of light is not visible in true solution. But this beam of light is visible in colloidal solution since the path of the beam is being illuminated. This effect was first observed by Faraday and later studied in detail by Tyndall and is termed as Tyndall effect. And the bright illuminated light is called as Tyndall cone. Tyndall effect is due to the fact that the colloidal particles scatter light in all directions in space. And this scattering of light by the colloidal particles eliminates the path of the beam of light in colloidal solution. Purification of colloids is done by the process of dialysis and electrodialysis. Dialysis is a process of removing the dissolved substance from colloidal solution by means of diffusion through suitable membrane. Apparatus used is termed as dialyzer. It contains a bag of colloidal solution which is impure, and this bag is made up of a suitable membrane, and it is suspended in a vessel through which fresh water is continuously flowing. Molecules and ions present in the colloidal solution diffuse through the membrane into the outer water, and pure colloidal solution is left behind. Ordinarily, the dialysis process is quite slow. So it is made faster by applying an electric field. So for that, the electrodialysis is being done. And this electrodialysis is a process when the substance in the colloidal solution is only an electrolyte. Now electric field is applied by using the two electrodes anode and cathode, which are positive and negatively charged. Ions inside the colloidal solution migrate out to the oppositely charged electrodes and thus makes the colloidal solution pure. One of the methods for preparing colloidal solution is peptization dispersion. Peptization is a process of converting a precipitate into a colloidal sol by shaking it with the dispersion medium in the presence of a small amount of electrolyte. So electrolyte used here is a peptizing agent, and this method is used to convert a freshly prepared precipitate into a colloidal sol. Dear students, I hope you must have understood this topic. Keep learning, keep exploring. Thanks for watching. Please like, share and subscribe to our channel for more informative videos.